Hi everyone, welcome to week 8 of 10 in Math 90. My name's John and I'm here to walk you through the content for this week. So what are the objectives that we're going to be talking about? Well, we're going to be doing a lot of solving equations, but then we're also going to do some solving inequalities. So we're going to start by simplifying and solving equations using subtraction and addition property of equality. This is review. We're going to solve equations with variables on both sides. We've done a little bit of that so far as well. We're going to solve equations with fractions or decimal coefficients. Okay. Then we're going to get into solving linear inequalities. And I think the biggest obstacle there is just making sure that we understand how interval notation works so that when we put our answers into Newton, we get credit for knowing what we were doing. All right, so let's start with solving equations using subtraction and addition properties of equality. As we've been saying all along, if we're trying to get a variable by itself and that variable is having something done to it, then we want to make sure that we do the opposite to undo that. We're reverse engineering what's happening to the variable so that we can figure out what that variable has for a value. So in this case, m is being subtracted, or 315 is being subtracted from m. So we want to add 315 to both sides of the equation to get rid of that. Now m minus 315 plus 315 is just m. And then negative 410 plus 315 is going to give us negative 95. You might have noticed I've got a calculator here that I'm using. I suggest you do the same. For the second problem, we have a plus 262, so 262 is being added to a, so to undo that, we want to subtract 262 from both sides. So a is equal to negative 301 minus 262, which is negative 563. And finally, we have b. And b has 110 added to it, so to undo adding by 110, we're going to subtract 110, and we need to do that from both sides. It's going to go b on the left side, and on the right side we have 58 minus 110, which is negative 52. So that's a quick review of using the addition and subtraction properties of equality to solve an equation. Now we're going to move on to something that looks a little bit more difficult. Okay? Last week we talked about the distributive property. So I have this negative 6 that needs to be distributed into this set of parentheses. That's going to be my first move here. So I have 7x minus 6x, because negative 6 times x is negative 6x. And then negative 6 times negative 5 is going to give me positive 30 plus the 3 that we have there equals negative 17. And so now we're going to make sure we combine our like terms. So we have 7x minus 6x. Those are like terms. We also have 30 and 3. Those are like terms. So we're going to combine like terms to simplify this side of the equation a little bit. So 7x minus 6x is just x. And then plus 33 equals negative 17. And look at that. In the span of a couple of steps, we've gone from something that looks scary and difficult and unintuitive to something that looks exactly like the problems we were just doing on the previous slide. X has 33 being added to it. We want to get rid of the 33, so we're going to subtract by 33 to undo adding 33. And so that leaves us with x on the left side of the equation And on the right side, we have negative 17 minus 33, which is negative 50. Always a good idea to plug your answer back into the original equation and check that both sides of the equal sign are the same. Whew. All right. So we went from something that was a little scary to something that looks really scary. But again, we're just going to take it one step at a time, and that's how we get through this. We're going to do what we know how to do, and eventually things will work out. So I do have things being multiplied over addition and subtraction. In this case, it's all subtraction. So I have to distribute the 5 into here. I do not distribute this negative 6 here. And the reason is this is not 5 plus y. This is 5 times y. So this really could be written 6 times 5 times y. And so there's no distributing there. This is just negative 30y. And we'll get to that in a second. But we also want to distribute the negative 3 into here. And we want to distribute the positive 4 into here. So that's my first step. That's all I'm going to do in this step. 35y minus 10. And then I'm going to leave everything else alone. I am going to use the associative property that we talked about last week to group the parentheses a little bit different here to show you that this is really just 30y minus 4y equals 14 minus 12y plus 24. And then look at me running out of room. I think if I do this, I can move everything over. Okay. And then we are going to add 12y and subtract 24. All right, so all we did in that step was the distribution. Now we're going to go ahead and clean stuff up by combining like terms on the left and right side of this equation. This is really just a 30y. I'm not going to write out a whole new step just for that. So we have 35y minus 30y minus 4y. That's just going to give us y minus the 10 that was here. So this is here. Equals 14 plus 24 minus 24. So 24 minus 24, those are going to cancel. So I'm just left with 14 here. And then negative 12y plus 12y, those are going to cancel. So I'm really just left with 14 there. And see how much this simplified within a couple of steps. We have y minus 10 equals 14. We want to get y by itself. 10 is being subtracted from y, so we're going to add 10 to undo that subtraction. Y is equal to 24. All right, moving on. So, we also have things like the multiplication and division properties of equality, but again, this is review. We're just solving equations here. They're using fancy lingo, but we're going to combine like terms, and then we're going to solve for the variable. So in this case, we have 4r minus 5r. 4 minus 5 is negative 1. Excuse me one second. So we have negative r here. And then 10 minus 17 is negative 7. Now r is not completely by itself here, so we want to make sure that we are getting r totally by itself. So the negative 1, there's a negative 1 in front of r. So that's being multiplied by r. So we want to divide by -1. So r is going to equal 7. Excuse me for 1 second. All right, moving on to the next one. Again, we want to use the distributive property. We're going to distribute 4 to both the x and the -12. So that's going to give us 4x minus 48 minus the 2 that was already there equals -34. -48 minus 2 is -50. So first step here, x is being multiplied by 4, and then 50 is being subtracted from that. We want to do the reverse order of operations to reverse engineer this. So first we're going to add 50. And -34 plus 50 is going to give me 16. And then to get x totally by itself, I'm going to divide by 4 to undo the multiplying by 4. And that's going to give me x equals 4. All right. Moving along. So that's the first objective. We used some of our equations, properties of equality. Now we're going to solve equations that have variables on both sides. We've already looked at this a little bit, so let's solidify it. So my choice, and it doesn't matter which way you go here, you can move all the constants to the left side and all the variables to the right side of the equation. You could move all the variables to the left side and the constants to the right side. There's no right or wrong answer here. Remember, an equal sign means that the two sides are not even different. So whatever you're comfortable with is fine. What I'm going to suggest is I like to make sure that we don't end up with a lot of negative signs in front of the variable coefficient, because that's where silly mistakes happen, is with negative signs. And so in this case, if I could either add 5a to both sides of this equation, or I could add 10a to both sides of this equation to get the variable terms on one side. I'm going to opt to add 10a to both sides of the equation. And the reason I'm doing this is because -5a plus 10a is going to give me a positive value of 5a. And again, that's what I'm trying for here, is a positive coefficient. So what we have is a positive 5a minus 8 equals 27. And now we're back in the same boat we were in before. In the last problem, we had something that looked very similar. We had 4x minus 50 equals -34. This is 5a minus 8 equals positive 27. So we want to go in the reverse order of operations. We're going to start by adding 8. So we're going to add 8 to both sides to undo subtracting by 8. So this gives me 5a equals 35. And now to undo multiplying a by 5, I'm going to divide both sides by 5, and that's going to give me a equals 7. All right. Next example. All right, this one's more complicated, but we have the tools necessary to get through this. The first thing we're going to do is get rid of all the parentheses, and in order to do that, we're going to distribute any constants through. So here we're going to distribute the 3 to those two terms, and we're going to distribute the 8 to these two terms. So 3 times negative 9n is negative 27n. 3 times negative 21 is negative 63. We still have the plus 11 that was already there. Then 8 times n gives me 8n. 8 times negative 1 gives me negative 8. And we still have the negative 9, or the minus 9, that was already there. So now we're going to combine like terms on both sides. There aren't more than one variable term on either side of the equation. And so we're just combining the constants here. So we have negative 27n, and then negative 63 plus 11 gives me negative 52. On the right side of the equation, the 8n is going to stay how it is. And we have negative 8 minus 9. Negative 8 minus 9 is going to give us negative 17. So at this point, we are exactly where we were in the last problem when the last problem first started. So we have variables on both sides. We have constants on both sides. We can put the variables on the left side of the equation and the constants on the right side. But I'm actually going to opt to add 27n in this case, because if I subtract 8n, I'm going to have a negative coefficient in front of the variable. So I'm choosing, there's no one way to do this. This is my choice. You make your choice. I'm making mine. I'm going to add 27n to both sides. That's going to leave me with negative 52 equals 35n minus 17. Since I added 27n to both sides, I no longer have any variables on the left side of the equation. So that's where the constants should go. So I'm going to add 17 to bring the 17 back over to the other side. So this is going to be, let me add 17 to both sides of the equation. That's going to give me negative 35 equals 35n. And so now the last step is to get n by itself, is to divide by the 35 that's being multiplied. So dividing by 35 on both sides is my next step. So on the right side of the equation, I just have n. On the left side of the equation, give me 1 second. On the left side of the equation, I have negative 35 divided by 35, which is negative 1. Sorry for the delay there. My tablet crashed and had to restart. All right. So sometimes you're going to be just in the zone and you're going to be solving these equations, and then something weird's going to happen. So let me show you what that looks like and how to deal with the weird thing happening. So our goal here, just like always, let's get rid of the parentheses by distributing. So I'm distributing the 12 through. 12 times 3x is 36x plus 12 equals 36x minus 45. So I know what's going to happen here, and so I can recognize that something is strange about this equation. But you might just be in the zone. You know that your next step here is to get the variables to one side of the equation, so you decide to subtract 36 from both sides. But when we do that, we just get 12 equals negative 45. The variable disappears. 36x on the right side of the equation minus 36x is no x's. And then on the left side of the equation, we had 36x, and we subtracted 36x from that, which leaves us with no x's. So now we just have this statement that says 12 is equal to negative 45. And in my head, I know that that's not true. 12 is not equal to negative 45. And so this is what we call a contradiction. There's actually no solution to this equation. There is not a number that would make this equation true, ever. So it's a contradiction. And you can see the heading changed, and we have these three words that aren't really all that important when it comes to, the life of a mathematician. But it's important to understand what they mean. So a contradiction is exactly this. We end up with a mathematical sentence that doesn't make sense. 12 doesn't equal negative 45. And we didn't do anything mathematically wrong to try to solve this equation. We used the properties of equality that we've been using. We did everything we were supposed to do, but there's still no solution to this problem because the original setup was a contradiction. Another thing that can happen when you're working through these kinds of problems is we would, again, distribute the 4, distribute the 3. Here we have 12k plus 24. And on the right side, we have 12k plus 24. Again, you might look at this and say, that looks a little strange. I have the same thing equal to itself. And it is a little strange because now when I go to try to get the variables to one side of the equation, I get that same issue where I subtract 12k from both sides and I end up with 24 equals 24. Now this is a true statement. That is absolutely true. And because the variables disappeared, now I'm like oddly aware of where I am in this problem, thinking, well, that shouldn't have happened. How do I solve for a variable if there's no variable left in the equation? And this is what we call an identity. So identity is really just recalling the identity element gives you back what you started with. So here, we're just saying 24 is equal to 24. That's just a true fact. That's an identity. And so what that means is that there are infinitely many solutions. Infinitely many. And that's called an identity. So we have conditional, identity, and contradiction. But we haven't talked about conditional. Well, conditional is just any other problem where the variable equals a number. So when you get a variable equals number, which is 99% of the time, that is a conditional equation, and you wouldn't need to know that name because that's what happens most of the time. It's when the variable disappears that you have to be aware of what's going on and notice whether it's a contradiction, the two sides are not equal, or it's an identity, the two sides are equal. All right, so now let's move on to solving equations with fraction coefficients. Now, I know how much you all enjoyed week 4 of this course with fractions, so let's make it so we don't have to deal with fractions. That is the point of this, is we are going to get rid of the fraction and then make this look like one of the previous kinds of problems that we dealt with. So in this first example, we have a 1/5 out in front on the left side. We have a 2/5 out in front on the right side. Normally, we would distribute this on both sides, or to both the terms inside the parentheses. And I can still do that. It looks like in this problem, it would work out okay. But if I distribute a fraction into other numbers, I'm usually going to end up with fractions. And so distributing is not going to be my first move for this particular problem. Instead, what I want to do is I want to eliminate the fraction altogether, or at least the denominator of it. So the denominators are both 5 here, which is nice. Because that means what I can do is, first I'm just going to rewrite this so that when I do what I do, it's nice and organized. I'm actually going to leave a little bit of space out in front here. So that's my original equation rewritten. Now I'm going to go ahead and multiply both sides of the equation by 5. And I'm choosing 5 because 5 is the least common denominator. The denominators are both 5, so the least common denominator is 5. And what that allows me to do here is 5 times 1/5 is just 1, and 5 times 2/5 leaves me with 2. And so the equation becomes 10x plus 15. Technically, there's a 1 in front of it, but if I have a 1 in front of a set of parentheses, I don't really need that there. So I'm just going to undo that. But I do have a 2 in front of the set of parentheses over here. So I want to make sure I keep the parentheses in place. Now this problem is just like the problems we've been doing this whole class, or this whole webinar. And so we are going to distribute the 2 over here. We have 10x plus 15 equals 10x minus 40. Now I'm noticing I have a 10x and a 10x, but I'm also noticing that 15 and negative 40 are not equal. So I can continue to solve this by subtracting 10 from both sides, or I can already see that this is a contradiction and there's no solution. Let's do another one. Okay. Here we have 2 fractions in front of parentheses on either side of the equation again, just like with the last one. But in this case, we do not have common denominators. And so I need to find the least common multiple between 3 and 4. And the least common denominator for 3 and 4 would be 12. And so I'm actually going to multiply both sides of the equation by 12. And last week we kind of did a problem where I said, let's make the number smaller before we make it bigger. 12 divided by negative 3 is negative 4. Times 1 is still negative 4. So on the left side of the equation, 12 times the negative 1/3 gives me negative 4. On the right side of the equation, we have 12 divided by 4 is 3. but then times the 5 that's there gives me a 5. Sorry, gives me a 15. 3 times 5 is 15. And we still have the x minus 2 in the parentheses. So what I did was I multiplied through by the least common denominator, 12. And if you're struggling with how I got the 15, you can always just put in 5 divided by 4 times 12, and it will give you 15 on the calculator. But the idea here is I'm doing 12 divided by 4, which is 3, times 15, times 5. Wow, I really can't say this. Okay, I'm going to do it one more time. I have 12 divided by 4, which is 3, times 5, which gives me 15. Whew, I did it. So now I can go ahead and tackle this problem like I would any other. Distribute. Negative 4 times 2x is negative 8x minus 4 equals 15x minus 30. It does not appear that the variables are going to cancel out for this problem, so I'm going to continue. I'm going to add 8x to both sides because of what I talked about earlier. I like the positive values to be in front of the variable. So this gives me negative 4 equals 23x minus 30. I'm going to add 30 to both sides. That's going to give me 26 equals 23x. Divide by 23. X is equal to 26 over 23. And I believe 26 divided by 23, math fraction, is 26 divided by 23. You cannot reduce that any further. So we did end up with a fraction as an answer, but we did not have to deal with fractions at all until the very last step, because we got rid of them in the first step. But what if you have a decimal coefficient? Well, this is actually easier. You can use your calculator if you want, obviously, and again, you can still distribute this if you'd like, but I'd rather not deal with decimals if I don't have to deal with decimals. So what I'm going to do is I'm going to get rid of the decimal. You can see all 3 decimals here are to the 10th place. The 10th place. And so if I'm in the 10th place and I multiply by 10, then I'm going to be whole number values. So 1/10 divided by 10 gives me negative 1. So what I'm doing here is I'm multiplying everything by 10 on either side of the equation. This 10 has to distribute. So that's where this negative 1 came from, was 10 times negative 0.1. That gives me negative 1. And now 10 times negative 0.2 is negative 2. And that equals negative 3.9 times 10, which is negative 39. Now I can go ahead and distribute this negative 1. That gives me negative x minus 3 minus 2x equals negative 39. Negative x minus 2x is negative 3x minus 3 equals negative 39. Add 3. Negative 3x equals negative 36. Divide by negative 3. X equals negative 36 divided by negative 3 is 12. Now, if you thought that this last process, going from here to here to here to here to the answer, was too fast, rewind it, watch it again. But as we get through more and more problems, your skills are getting better and better. I just know it. And so, you don't have to write every single step in between. If that's what makes you feel comfortable, then keep doing it. But you don't have to write every single step out if you're feeling comfortable and you're consistently getting correct answers. Don't feel like you need to do that. So here we have, again, 3 decimals, but now everything that's a decimal is to the hundredths place. So instead of multiplying by 10, I'm going to multiply both sides of the equation by 100. And please, the square brackets don't mean anything different than parentheses. Just sometimes use square brackets instead of parentheses. There was already a set of parentheses on the left side of the equation, so I put the square brackets there because I like the visual difference between grouping symbols. But this 100 has to distribute to both terms. So this is going to give me 3 times c plus 4 minus 2c equals negative 105. We distribute 3c plus 12 minus 2c equals negative 105. Combine like terms, c plus 12 equals negative 105. Subtract 12. Negative 105 minus 12 is negative 117. That's all there is to it. So again, the important step here is if all the decimals match up with the same number of decimal places, then you can multiply each term by that place. So if it's in the hundredths place, you'd multiply by 100. If it was in the thousandths place, you'd multiply by 1,000, and so on and so forth. All right. So we are getting near the end here. The issue is this last topic, okay? In order to be successful in this last topic, you need to understand interval notation. And I'm going to go through all of that for you. Okay, we're solving inequalities. Solving linear inequalities are actually very similar to solving equations. In fact, you would solve like an equation. The one thing that's different is if you multiply or divide by a negative number. You must flip the inequality. So let me be very clear. We are going to make sure that it's only when we're multiplying or dividing by a negative number, not when we're multiplying a negative number by a positive number, but when we're multiplying both sides of the equation, you must flip the inequality. So if it's greater than, it becomes less than. If it's less than, it becomes greater than. So I'm going to go through this problem in a way. This one, it's not going to happen, but we're going to go through this the normal way. So you're going to solve like an equation. So in this case, I'm going to combine my like terms on the left side. And that leaves me with 6m minus 18 on the right side. Now I want to get all my variables to one side, so I'm going to subtract 6m from both sides of the equation. I'm not multiplying or dividing. I'm subtracting. So we just keep going like this is a regular equation. 15 minus 6 is 9m, is greater than negative 18. Greater than or equal to negative 18. So next, we want to get m by itself. We're going to divide by positive 9. I'm dividing by a positive number. There's a negative number involved in that division, but what I'm dividing by is positive. So I'm going to keep everything the way that it is. I'm not going to change anything. M is greater than or equal to negative 2. This is my answer. However, Newton doesn't want you to put your answer like this. They want you to write your answer in interval notation. So what interval notation is you can think of putting your answer on a number line. Okay? And say that this is 0, 1, 2, 3, 4. This goes on forever. That's what the arrows mean. Negative 1, negative 2, negative 3. Negative 4. Okay. So we have a number line. The representation of this answer that I just got, m is greater than or equal to negative 2. The representation on this number line is I would have a filled in circle on negative 2 because I'm also equal to negative 2. I'm not just greater than, I'm also equal to negative 2. So we show that on a number line by filling in the circle. And then every answer that is to the right of that is greater than that number, is a solution to this problem. So I can pick anything along the purple here, and that will be a solution to this. It will make the original equation true. For example, if I plug in 0, which is along the purple line, 0 plus 0 is 0 on the left side of the equation. 0 minus 18 is negative 18 on the right side of the equation. 0 is greater than negative 18, so that is a true statement, which is why this number works. So the way that interval notation works is thinking about the number line and starting at the leftmost point of our shaded area. In this case, it's negative 2. So we're starting to the leftmost point, negative 2. Then we travel right as far as we can. Now this thing has an arrow to the right, which means that we're going to go all the way to infinity. So we have left and right number. Leftmost value, rightmost value. The leftmost value is either going to be a number or it's going to be negative infinity. The rightmost value is either going to be a number or positive infinity. Never have negative infinity on the right side because on the number line, negative infinity is left. Okay? So we start with the smallest number that's part of our solution, in this case, negative 2. Now, a square bracket is used when we are also equal to that number. If we have a filled in circle on the number line, we use a square bracket. For infinity or negative infinity, we're always going to use a parenthesis because the parenthesis means we're not including that value in the answer. You can't include infinity because infinity is not a number. Infinity is an idea. You tell me a number that you think is infinity and that you think we could be equal to. Let's just say you say 10 million, and I'll just go 10,000,001. So we didn't actually we can't get to infinity, so we can't be equal to it because there's always another number. If you think you found the biggest number, I'll just add 1 to it and show you a bigger number. And that will work forever. We could play that game for a very long time and no one will win. All right. So this is the actual answer to this problem. And this is what you need to be putting into Newton. Square bracket -2, comma, infinity, parentheses. And this is where people fall down. It's not that you didn't get m is greater than or equal to -2. I'm sure you got that answer. But then translating that into interval notation, that's the tough part. Just realize that if you have your variable on the left side of the equation, which I highly recommend. So in this case, we had m is greater than or equal to -2. If the arrow is pointing to the right, you will have an answer that looks like negative infinity on the right side of your interval. So pointing right, infinity on the right side. Okay? If you have something that's less than pointing to the left, then you'll have negative infinity on the left side. I'm not going to write it here because I don't want to get people confused, but we will see a problem that looks like that. All right. So we're going to try another one here. We're going to solve this. So the first thing I'm going to do is solve it like an equation. So my first step would be distribute. Distribute. 8y minus 3y plus 6, -3 times -2 is plus 6, is greater than 2y plus 8y plus 16. Okay, let's combine our like terms. We have 5y plus 6 is greater than 10y plus 16. Now I know that when we solve equations, I say that I would like the variable to have a positive coefficient. But with inequalities, I think it's more important that your variable's on the left side of the inequality. So I am going to subtract 10y from both sides. Gives me -5y plus 6 is greater than 16. Subtract 6 from both sides. -5y is greater than 10. Now, to get y totally by itself, I need to divide by -5. I am dividing both sides of the inequality by a negative number. So what happens here is I do have y, and I do have -2. That hasn't changed. -5y divided by -5 is y. 10 divided by -5 is -2. But what was greater than before is now less than. Switch inequality. I divided by a negative number. I need to switch the inequality. It was greater than, now it's less than. And now I have a variable by itself on the left side of the inequality. I have an arrow pointing left. Okay, let's think about the number line. So I have a number line, and now at -2, I actually have an open circle. So I'm not going to fill in that circle. It's an open circle because I am not equal to, I am just less than. And the open circle suggests that we're getting infinitely close to -2, but we don't actually ever equal -2. So anything that's less than -2 would be in this direction to the left, less than is left. And so the arrow in this case, if we start as far left as we can think of, that is negative infinity. And the shaded area starts at negative infinity and ends at negative 2. But we're not including negative 2 in that value. So we're not going to use a square bracket. We're going to use parentheses. So there's a couple things going on here. One, the inequality is pointing left. So we start with negative infinity in our interval. Two, the second thing that's happening is we have a less than not equal to. Sorry, that was really messy. So because it's not equal to, there should be no square brackets. No square brackets. If I see an equal to, I should have one square bracket. If I see no equal to, I should have no square brackets. This is my answer. Starting at negative infinity is as far left as I can go. Ending at negative 2, that's as far right as I can go. But we're not including negative 2, so it's a parenthesis there. Let's do one more, and then we're done. All right. We have fractions again. I don't want to deal with fractions with equations. I don't want to do it with inequalities either. So let's go ahead and fix that. Least common denominator between, or least common multiple between 3, 7, 21, and 6. If I do multiples, 3, 6, 9, 12, 15, 18, 21. Okay. 7, 14, 21. 21. 6, 12, 18, 24. Ah, okay. So 21's not going to do it, but guess what will? One more 21. So 42 is definitely going to make it because 6 does go into 42. So 42 is my common denominator. So I'm going to multiply through by 42 on both sides of this inequality. What I'm noticing about the inequality is that there's an equal to. There's an equal to. That's going to give me a square bracket. I know that right from the beginning. I'm going to have one square bracket in my answer. And I have one square bracket in my answer. I already know that. I don't know which way it's going to be facing yet, because I could have a negative that I multiply by or divide by. And so I can't make the decision whether my final answer is going to have an inequality that's pointing left or pointing right. But if I multiply through by 42 here, 42 divided by 3 is 14. So this is going to give me 14x, and then 42 divided by 7 is 6, plus 6x. This is greater than or equal to 42 divided by 21 is 2 times 10 is 20x. And then 42 divided by 6 is 7. So I don't know about you guys out there, but I would much rather solve this second inequality that I have written than the first one. They're the same inequality. I just made it look different. And this one looks way more appealing. So now I have 20x is greater than or equal to 20x minus 7. I try to solve by subtracting 20x from both sides. That gives me 0 is greater than or equal to -7. Here we are. This is one of the problems where the variables completely disappear. And I know we did that with equations, but it also is true for inequalities. And so, unfortunately, we're not going to get to practice with our square brackets because this is a true statement. And because it's a true statement, our answer in interval notation is going to be all the numbers. I can put any number into this inequality and it will be true. And the way that we write all the numbers in interval notation is we start at -infinity and we go all the way to +infinity. And that is interval notation for all the numbers on the number line. And so that would actually be my final answer. Okay. This is what I recommend everybody does. I recommend you get through the equation stuff fast. Do all the homeworks associated with the solving equation stuff. Then work on the linear inequalities and give yourself plenty of time to do that. Check out the videos on the Math Lab website on My Nightingale. And if you're struggling, use your resources. If the Math Lab videos still aren't helping, Teams message someone from the Math Lab or foundational coaches and ask your question. Reach out to your instructor. Make sure that you understand linear inequalities and interval notation before you go into your quiz for this week. Please. Set up a one-on-one through bookings or go to a drop-in study hall if you want some face-to-face time with a coach. All right, I hope this was helpful. And I love that you're here at Nightingale. Feel free to share this with a fellow learner who might not be aware of it, or watch this video again. It'll help. All right. See you next week.